Hey guys, welcome to another episode of Cuda Education. Today I wanted to talk about frames per second. So if you look up here, we're currently running at 400 and about between 20 and 60 frames per second. And as you can see, the animation is pretty smooth. So even if you look at these rocks, it's for the most part animating pretty smoothly. We don't have too much issues in terms of rendering the rocks and what it is that it's trying to what it is that it's trying to show. It's pretty smooth. It's smooth to the eye. All the images, all the rotations are changing pretty nicely. We don't have a problem with it, right? And if we zoom into some more rocks, we could see that we have a pretty reliable rendering, right? Everything looks like it's going according to plan. And of course, we have our planet here. Looks like a bleak planet, but it's all right. So this is, in a situation where everything is going according to plan. So about 8,192 rocks that we have that's being rendered across all of these things, right? So that is when things are running good. Now what I'm going to do is I'm going to change the asset that is being run to something a little bit more complex, and we're going to see what happens. All right? Okay, so here now we have a situation where we are rotating plants. And notice that the frame rate now is significantly lower. And the reason it's significantly lower is because if you look at these plants, there's a whole lot more detail and textures and things to manipulate as it relates to the plant. So as a result, there's a lot more drawing that the GPU has to do. And as a result, every instance of these plants rotating, it's a lot more complex. There's a lot more work that needs to be done. If you notice that it's a little bit more jittery, it's a little bit more stuttering, it's not clean to the eye. You could kind of see literally one frame changing over to the other. It's just not smooth. And that is because the frames per second, as you can see, the frames per second is a lot lower. So the eye generally has a threshold of 30 frames per second. And the higher the frame rate is, the smoother you see movements in a rotation or in a animation or in a film or any kind of image computer graphics rendering. You want high frame rates, but here we have lower frame rates. So you could just see, just from the overall gist of things, outside of it being a tree, you could just see that it's not as smooth. The animations aren't as smooth. You could literally see this thing. It's not as clean. So that's pretty much my quick example of frames per second and why it's important to make sure that your computer graphics algorithm is very efficient. It makes good use of memory. It makes good use of the GPU resources processing. It tries to reuse things as best as possible. And make it fast as possible. So yeah. So let me do one other thing and get back to you. All right, now here we can see the same rendering, but I've cut down a lot on the number of trees that are in the circles. So as you can see, things are running a whole lot smoother, right? It's running a whole lot smoother. It's not stuttering as much. we have a frames per second of 400, 500 FPS. And you can see that the animation is a lot cleaner. And that, of course, is simply because I don't have as many trees rotating in the animation. So therefore, you know, there's more resources, there's more, the GPU has more capability to make the animations cleaner. There's time to get it to render. We're seeing more frames. And what a frame is pretty much is like, you remember in school when you would want to make an animation, so towards the end of a notebook or a set of pages, you would like draw a stick figure. So you would draw a stick figure of like the stick figure standing, then the stick figure moving. You know, the next page would be a stick figure with a foot in front of them. Then the next figure would be a stick figure with a foot in front of them, a little bit more and a little bit more. And then you would take your thumb and you would rapidly peel through all the pages in the notebook, so you get an animation of the stick figure. So the stick figure might be running, the stick figure might be jumping, the stick figure might be doing something else, but that's pretty much what frames per second is. So how many frames, how many different drawings are hitting your eye in a second? FPS, how many frames are hitting your eye in a second? And when you have a high frame rate, you get smooth animations, right? Nothing that's you know, nothing that seems jittery, nothing that's stuttering, nothing like something is wrong, like the computer is gonna crash or anything. It's just smooth and clean. So that, ladies and gentlemen, is my discussion on frames per second. Shout out to the powers that be that made this code freely available, and the assets and everything. But yes, guys. So I'm going to, you know, eventually in my tutorials, I'm gonna be talking when I'm working through the example with this application. I'm going to be talking about frames per second and all of that stuff. Again, we want to make our applications, our computer graphics applications, we want to make it efficient so that we could keep up our frames per second. See, I only have 100 instances of these things. We want it efficient so we could keep up our frames per second. And that's the beautiful thing about Vulkan, is that Vulkan, it has, because it's built from scratch, sort of, with a GPU in mind, with parallel processing in mind, it's a lot more efficient than OpenGL, which is the older framework for computer graphics. So that's my discussion on frames per second. Definitely check out the tutorials. I'll have a link below for all of my Vulkan tutorials. Definitely check that out. And definitely visit CudaEducation.com. Learn Vulkan. Vulkan is the future. Vulkan is where digital is heading. You know, we're gonna have holograms soon. We already have VR in the pipeline and all kinds of other technologies. So you want to get started with computer graphics. Get some of your friends together and you guys just work through the different examples. You know, get a computer with an NVIDIA or AMD graphics card where you can, you know, where you could start programming computer graphics applications and get the ball rolling. This is the future, but you can't wait until the future arrives. You have to start putting in the work and putting in the effort beforehand so that when it becomes in vogue, you're already there. All right. Thank you guys for listening to my video. Like and subscribe and all that good YouTube stuff. And I'll see you next time.